In this exercise, you'll create a three-way intersection and generate a corridor that maintains the crowns of both roads. To create a complete intersection model, you must have a centerline alignment and profile for each of the intersecting roads. The horizontal and vertical geometry for the remaining elements, including the offsets and curb returns, is generated based on the parameters you specify. In a peer road intersection, the crowns of all intersecting roads are held at a common grade. The pavement for both roads is blended into the curb return regions, which form the transitions between the intersecting roads. The drawing for this exercise contains a corridor along each of the intersecting roads. Each corridor is made up of a corridor assembly and a centerline alignment and profile. So let's specify the intersection location. Go ahead and open up your intersection-create-1 drawing in your tutorials folder. Then go ahead and go into your Home tab and then into your Create Design panel. Click the Intersections drop-down and select Create Intersection. Now our command line is asking us to select an intersection point. We're going to select this point right here between our two roads. Now this is an intersection point of the two alignments. Now we're going to be specifying the corridor grade parameters. We're currently in the Create Intersection wizard and we're on the General page. Go into your intersection corridor type, click the drop down, and we want to select all crowns maintained. You'll see in the graphic how that's going to be generated. Go ahead and click Next. Now we're going to specify the geometry of the offsets and curb returns. In the Geometry Details page, click Offset Parameters. Now note that the default parameters are stored in the drawing settings. You can modify the default parameters during the intersection creation process. Now in the Offset Parameters dialog box, specify the following parameters. Under the secondary road, we're going to specify a left offset alignment definition, and that offset value is going to be 3.5. Now let's look at the right. Go ahead and change that to 3.5. Now in this checkbox right here under Create New Offsets from Start to End of Center Lines, we're going to leave that checkbox cleared for right now. Although when this option is selected, offset alignments are created along the entire length of the centerline alignment. This option is useful when you need to use offset alignments and profiles as targets for other objects, including other intersections along the same road. Go ahead and click OK. Now we're back onto the Details page. Now the next step is to select this, Curb Return Parameters. In the Intersection Curb Return dialog box, under Curb Return Parameters, specify the following parameters. For the curb return type, we're going to leave its default at circular fillet. But for the radius, we're going to change that to 7.5. Now note that in the drawing, temporary graphics highlight the currently selected curb return. Go ahead and right-click on the curb return parameters. We're going to click to copy these to all quadrants. This command copies the curb return parameters to all intersection curb return regions. The number of curb return regions is automatically generated based on the existing horizontal geometry. For example, if this was a four-way intersection, 4 curb return regions would be available. I'll go ahead and click OK. So now we're back to the intersection wizard. Let's focus our attention on offset and curb return profiles in this region right here. Make sure that this checkbox is selected to create offset and curb return profiles. To produce a complete corridor model of the intersection, it's necessary to create profiles for the offset alignments and curb return alignments. For this exercise, you'll accept the default offset and curb return profile settings. So go ahead and click Next. Next, let's specify the corridor parameters. In the Corridor Regions page, specify the following options. Make sure that the checkbox for Create Corridors in the Intersection area is checked off. We want to add to an existing corridor, and make sure that 2nd Street is selected. For the surface to daylight to, we're going to leave it on the existing grade. Now we're going to select an assembly set to import. Go ahead and choose Browse. Go ahead and navigate to your Tutorials folder. Then go to this XML file, intersection assembly set allcrowns.xml. Select that, then click Open. An assembly set enables you to quickly import a group of existing corridor assemblies and then apply them to specific section types. Now, let's go ahead and create our intersection. The intersection is created and new corridor regions are created in the intersection area, as you can see right here. Let's examine the new objects. In the tool space, under the prospector, go ahead and look at your alignments. Go ahead and expand that. Expand your center line, your offset alignments, and curb return alignments. We'll open up our tool space just a little bit more to see everything. At the beginning of this exercise, only centerline alignments existed. The offset alignments and curb return alignments were created using the parameters that you specified in the Create Intersection wizard. Note, in the drawing, the offset alignments and station labels are blue, and the curb return alignments are red. Under the offset alignments, go ahead and expand the 1st Street left offset alignment. Next, expand the Profiles collection. Layout profiles for the offset alignments and curb return alignments were created using the parameters that you specified in the Create Intersection wizard. Let's go about closing these gaps in our corridor for 2nd Street. In the drawing, select the corridor in the intersection area. You'll see that we have grip sliders at the start and end of our corridor regions. Click the 2nd Street corridor. You'll see a grip at station 040. Go ahead and select that grip. Notice how it turns red. Now, in the command line, type in 21. We've now closed the gap between the 2nd Street corridor and our intersection. Next, let's go ahead and fill in this gap right here. Go ahead and escape out of the command, select the 2nd Street corridor, and now select Copy Region. Select the portion of the corridor that loops around the site. Now the command line is asking us to specify the start region, station, or fill. We want to choose fill. Now we have to specify the region location. If we hover over our gap, you'll see a red line that appears, showing that this is the gap that's going to be filled. Go ahead and click that area. So now the gap is filled. Go ahead and press Enter to exit the command. Let's rebuild all of our corridors. The 2nd Street corridor rebuilds, eliminating the gaps. Now, let's select the 1st Street corridor. We want to eliminate this gap between our two corridors right here. Go ahead and select our grip. Notice how it turns red, and then slide it to the beginning of our intersection, which is right about here. So that's how you go about creating a pier road intersection in Civil 3D. In this exercise, you'll create an intersection with entry and exit turn lanes at the primary road. The secondary road crown will blend into the primary road edge of pavement. You can use the workflow that's demonstrated in this exercise to create an intersection with any combination of turn lanes and curb returns. Let's specify the intersection location and primary road. Go ahead and open up your intersection-create-2 drawing in your tutorials folder. Go ahead and go to your Home tab and then to your Create Design panel. Next, go to your Intersections drop-down and select Create Intersection. The command line is now asking us to select an intersection point. Go ahead and select this one right here, the intersection point of Road A and Road B alignments. Click Road A to specify it as the primary road. Specify the corridor grade parameters. In the Create Intersection wizard, on the General page, under Intersection Corridor Type, we want to make sure that it stays on its default of primary road crown maintained. Go ahead and click Next. Now we're going to specify the horizontal and vertical geometry parameters. On the Geometry Details page, click Offset Parameters. Default horizontal and vertical geometry parameters are stored in the drawing settings. You can modify the default parameters during the intersection creation process. In the Offset Parameters dialog box, specify the following parameters. Under Primary Road, Left Offset Alignment Definition, select the offset value. We're going to change this to 6. Now go to the right offset value. We're going to change that to 6 as well. Now under the secondary road, we have a left offset value of 3. We're going to leave that as it is. The same goes for the right offset value. We're going to leave that at 3. Now click OK. On the Geometry Details page, click Curb Return Parameters. The default parameters for the first intersection quadrant are displayed in the Intersection Curb Return Parameters dialog box. In the drawing, if we move this to the side, the first quadrant is highlighted. Arrows indicate the direction of incoming and outgoing traffic. In the Intersection Curb Return dialog box, select Widen Turn Lane for outgoing road. The widening details at outgoing lane parameter collection is displayed in the property tree. When you highlight a property, the preview graphic at the bottom of the dialog box updates to illustrate the property in a typical intersection. Examine the default values that have been specified for this drawing, but do not change any of them. Go ahead and click Next. For the southeast quadrant, select Widen Turn Lane for incoming road. Then click Next. For the southwest quadrant, select Widen Turn Lane for outgoing road. Then click Next. For the northwest quadrant, select Widen Turn Lane for incoming road. Now we're going to click OK. In the Create Intersection wizard, make sure the checkbox for Create Offset and Curb Return Profiles is selected. Then click Next. Lastly, let's specify the corridor parameters. On the Corridor Regions page, specify the following options. We're going to go ahead and create corridors in an intersection area, and we're going to create a new corridor. Now this new corridor will have a daylighted surface to our existing ground, and then we want to select an assembly set to import. Go ahead and click Browse. Now within your Tutorials folder, you have an Assemblies folder, and then Metric, and under the Metric folder we have Autodesk Metric Assembly Sets.xml. Go ahead and select that and click Open. Then focus your attention on the Maintain Priority Road Crown. Under Curb Return Fillets, select this button right here. Now this dialog box is asking us to select an assembly. You can use the Select Assembly dialog box to substitute an assembly with another assembly that is in the current drawing. To save your changes as a new assembly set, click Save As Set on the Corridor Regions page. For this exercise, you'll accept the default assembly set. Go ahead and create intersection. The intersection is created and new corridor regions are created in the intersection area. Notice that the curb returns have widening regions to allow traffic to exit from and merge onto Road A. So that's how you go about creating a primary road intersection with turn lanes. In this exercise, you'll use the existing offset alignments and profiles of the primary road to create an intersection and then add the new intersection to the existing primary road corridor. The workflow that's demonstrated in this exercise is useful when you need to create several intersections along a single corridor. You define the offset geometry for the primary road and then reuse it for subsequent intersections. Let's start by specifying the intersection location and primary road. Go ahead and open up your intersection-create-3 drawing in your tutorials folder. Now this drawing contains an intersection of two alignments, Road A and Road C. Offset alignments exist on either side of Road A, and there is an existing intersection north of Road C. Go ahead and go to your Home tab and then to your Create Design panel. Click on the Intersections drop-down and select Create Intersection. In the drawing, our command line is asking us to select an intersection point. Go ahead and select the intersection of Road A and Road C. Next, our command line is asking us to select a main road alignment or press Enter to select from a list. Click the Road A alignment to specify it as the primary road. Now let's specify the corridor grade parameters. In the Create Intersection wizard on the General page, under the Corridor Type, make sure that the primary road crown is maintained. Go ahead and click Next. Now we're going to specify the horizontal geometry parameters. On the Geometry Details page, click the Offset Parameters. In the Offset Parameters dialog box, under the primary road, let's look at the left offset definition. We do want to use the existing alignment, so switch that to Yes. For the alignment name, go ahead and press this button right here. Now we're going to actually pick this alignment. In the drawing, select the offset alignment on the left-hand side of the Road A alignment. Go ahead and click OK. In the Intersection Offset Parameters dialog box, let's take a look at the right side. We're going to use an existing alignment. We're going to choose our alignment, and we're going to pick it in our drawing again. Now pick the right side of Road A. Go ahead and click OK, and then click OK. Now select Curb Return Parameters. The default parameters for the first intersection quadrant are displayed in the Intersection Curb Return Parameters dialog box. In the drawing, the first quadrant is already highlighted with arrows associated to indicate the direction of incoming and outgoing traffic. We're going to start with the southeast quadrant. Make sure that the Widen Turn Lane for Incoming Road checkbox is selected. Now select the northwest quadrant. We're going to do the same thing. We're going to make sure that this checkbox is checked for the incoming road. Now click OK. Now let's specify the vertical geometry parameters. On the Geometry Details page, under Offset and Curb Return Profiles, select Lane Slope Parameters. Now within the Intersection Lane Slope Parameters dialog box, specify the following options. Under the primary road, for the left edge profile definition, we are going to use an existing profile. And to choose that profile, we select that button right there, and then we're going to select Road A 2%. Click OK. Then we're going to repeat this for the right side. But for the profile name, we're going to select Road A 2% 1. Click OK, and then click OK. Lastly, we're going to specify the corridor parameters. Go ahead and click Next, and now we're on the Corridor Regions page. Let's specify the following options. Go ahead and check off Create Corridors in Intersection Area, but we're going to add to an existing corridor. We're going to add it to Corridor 1, and we're going to daylight to the existing ground surface. Under the Select Assembly Set to import, let's go ahead and click Browse and navigate to your Metric Assembly Sets. Select the Metric Assembly Sets.xml and click Open. Now go ahead and create intersection. And there you have it. That's how you go about creating an intersection with existing geometry in Civil 3D.